So software project estimation. The second part is software project estimation, under which we have LOC, line of code, FP, functional point, COCOMO, constructive cost modeler. 2. So we are going to learn the first part, that is line of code, LOC. Then we are going to learn FP, functional point analysis, COCOMO, constructive cost estimation model 2. Project software project estimation, size oriented metrics. LOC is LOC metrics, lines of code. It is one of the earliest and simpler metrics for calculating the size of computer programmer. To calculate the size of computer programmer, we will check for the lines of coding, how much lines have been given to coding, that will be checked. So LOC, lines of code, it is one of the earliest and simplest metrics for calculating the size of the computer programmer. It is generally used in calculating and comparing the productivity of programmers. So it is used for calculating the productivity of the programmers. How much has the programmer coded will decide the productivity of the programmer. These metrics are derived by normalizing the quality and productivity measures by considering the size of the product as a metric. Following are the points regarding the LOC measures. In size-oriented metrics, LOC is considered to be the normalization value. So in size-oriented, LOC is considered as a normalization value. It is an older method that was developed when Fortran and COBOL programming were very popular. So it was developed long back. Size-oriented metrics depend on programming language use. So size depends on the programming language. If I have a C language, then size of the program will be more as compared to a language like Python, where the size will be lesser, because you don't have to define the functions and all in the beginning, whereas for C you will have to define the function, and that will take a lot of lines. So to print hello world in C will consume more lines as compared to print a hello world program in Python. So size oriented metrics depend on the programming language. We say example, you have C versus Python programming language. As productivity depends on KLOC, so assembly language code will be more productive. So the codes which are written in the assembly language, that is language of the computer, that is you say the microprocessor language is assembly language, they are more productive. Fifth point, LOC measure requires a level of detail which may not be practically achievable. Sixth, the more expressive is the programming language, the lower is the productivity. The more the programming language is expressive, the lower is the productivity. LOC method of measurement does not apply to projects that deal with visual GUI based programming. As already explained, graphical user interfaces uses forms. Basically, LOC metrics is not applicable here. So this is your disadvantage of LOC metrics, that LOC metrics is not applicable for graphical user interface programming. It requires that all organizations must use the same method for counting LOC. This is so because some organizations use only executable statements, some useful comments, and some do not. Thus, the standard needs to be established. So, each and every organization has to use the same standards for counting the LOC. These metrics are not universally accepted. This is again a disadvantage, that these metrics are not universally accepted. So, what are the advantages of LOC? Simple to measure. So, LOC is very simple to measure. Most used metrics in cost estimation. It alternates have many problems as compared to this metric. So, alternative methods have problems as compared to the LOC metrics. So, LOC metrics is more effective as compared to the alternatives. It is very easy in estimating the efforts. So all these are advantages. Disadvantages of LOC. It is defined on the code. For example, it cannot measure the size of the specification. So it defined on the code how much lines are there in the code. According to that it is defined and not according to the size of specification. It categorizes only one specific view of size, namely length. It takes no account of functionality or complexity. So again, only it will see the lines of coding. That means how many lines are spent in that code, not the functionality or complexity factor. Bad software design may cause an excessive line of code. So again, LOC, what does it see? How many lines of code? So it says the more the lines of code, the more better. But it can happen that more the lines of code means more complicated will be the software. More the lines of code means there is a bad software designer. It is language dependent, like for example C versus Python. So it is dependent on the language, how much lines will be written for that particular same programmer. So for hello world, that is the same program, more lines will be there in C as compared to Python. So it is language dependent. Users cannot easily understand it. These are the disadvantages. So this is all about LOC, lines of code.